to write this down right now, but to do a little review on rational functions. Okay? Remember, I have those things on the graph that look like this. Look like that. What did we call those things? Asymptotes. Specifically, what's this one called? Horizontal. What's this one called? Vertical. Yep. Yep. Okay. So we talked about a few different types of graphs last time. If I do this, remember what the graph looks like. It's got two curves, right? Okay. Remember, all the ones that we did, except the one, the horizontal asymptote was always 0, right? Y equals 0. What's the vertical asymptote on this one? Well, it's the same as the NPV. What value of x would make this 0? 0. So therefore, there's going to be a break in the graph at x equals 0. And then it looked something like that. Okay. Then we have one that has some numbers attached to them. Do you remember what those numbers did? What's that? No, that's not. We're going to talk about that today. It moves. What does it move? The graph and the asymptotes, both of them. Because remember, the horizontal asymptote is normally here. This means it goes 3 down, right? Because that means, remember, there's a number at the end. The graph's going up or down. Because it's -3, it's going down. So the asymptote is going to be down here, the horizontal one. The vertical one is always the non-permissible value. What value of x would make this 0? What value of x would make this 0? -1. That's the vertical asymptote. And then it's going to look something like this. Okay. Then we had one that was very similar to the first one, except it had an x squared. Well, the horizontal asymptote is still the x-axis. The vertical asymptote is the NPV. What value of x makes this 0? 0. Do you remember what the shape of the graph looked like when there was just a squared on the bottom? What did I refer to it as? What shape? Yes? The volcano. Okay. What if it had something like this, except, let's see. So let's do this. Absolutely. Okay, absolutely. Yeah. Yeah. So first of all, we've got to, what can we do to the bottom? We can factor it. That will tell, because in order to find the NPVs, the vertical asymptotes, has to be in factored form if I can. So I'm going to get x plus 3, x minus 1. Remember, the horizontal asymptote is still this. But the vertical asymptote, there's two of them. Whatever value of x makes this 0, -3, and whatever value of x makes this 0, +1. So we're going to have two. We're going to have one at -1. We're going to have one at -3. So this one will be a little bit out here. We're going to have one at 1. And do you remember the shape this one took? The erupting volcano. Which means we have sort of the volcano on the outside, like so, like the previous one, except we've got an upside down parabola that represents the lava coming up. Okay? Finally, and this is all we're doing 6.4. We had one. There was an x squared on the bottom, but we couldn't factor it. Again, the horizontal asymptote was y equals 0. The only time this ever moved was when there was a number after the fraction, right? That was the only time it ever moved. We're going to see how it moves again today, because we're going to look at some different graphs. What value of x makes the denominator 0? You're shaking your head. Why? There is no vertical asymptote. There is no NPV, which means there's no vertical asymptote, which means I can go ahead and graph it. And how do you want to graph this one when there's a horizontal but not a vertical? Choose 0, 1, and -1 for your points. So if x is 0, y is going to work out to 2 times 0 squared plus 1, which is 2. If y is -1, -1 squared plus 1 is 2. Okay, so -1 squared is 1, plus 1 is 2. 2 divided 2 is 1. And if you do 1, you're also going to get 1 here. What was this shape? The speed bump. Okay. That was all from 6.4. Now, let's talk about 6.5. So you can see right from that first sentence, and we just saw that by all the ones we looked over. The thing with rational functions that make them a little bit challenging is that they can take so many different types of shapes. Okay? But generally there's curves involved. For the most part. Sometimes we're going to see there's not curves involved. We're actually going to see that pretty quickly, but I'll talk about that in a second. So one of the features is the vertical asymptote, or asymptotes if there's more than one. And they correspond to the non-permissible values of the equation. Not all NPVs, or non-permissible values, will necessarily be a vertical asymptote. And we're going to see that in a second. When that happens, we get what's called a point of discontinuity. That's the fancy word, the phrase that you don't have to worry about remembering. Remember it this way. It's a hole in the graph. And we're going to see that right away from this first example. Okay. First thing we want to do when we encounter a rational function, a fraction, is we want to make sure everything's factored. Numerator and denominator. Most of the time, it's the numerator. Sometimes it may be the denominator. Can I do any factoring here? Yes. What do I get when I factor the numerator? X minus 3, X minus 2, right? Now, you would think, you would say, okay, there's a horizontal asymptote on the x-axis. There's a vertical asymptote at x equals 3. So I draw a vertical asymptote. But do you notice anything you can do here? You can cancel out the x minus 3's, which means there's no longer a denominator, which means there's no vertical asymptote. But the graph is not defined at x equals 3. So what happens here is we end up with the equation y equals x minus 2, but a hole at x equals 3. So we have to graph this equation, but keep in mind that at the point x equals 3, y equals, well, what's y? How do I find y? So I just plug in x in here? Right? So that means there's a hole at the point 3, 1. We can go ahead and graph this here. There's a hole here. So I just put a hollow circle. How do we graph this? What kind of graph is this going to be? Don't overthink. There's no x squared. It's going to be a line. So I use y equals mx plus b. What's the y-intercept? What's the y-intercept of this line? -2. What's the slope? 1, and it's a fraction 1 over 1. So my y-intercept is -2. For a second point, I count out the slope, rise 1, run 1. Here's another point, and you can see how they all form a line. So it's going to look like this, but we've already established that it's not defined here. So it's this entire line is what the picture of the graph would look like, except for here because it's not defined. Bottom line is when you encounter one of these, make sure everything's factored first. Sometimes you don't have to do any factoring, like the previous ones we did in 6.4. We had to do some factoring, not much. Okay, but others we could draw right away without factoring. So here, what's the behavior between these two functions near their non-permissible values? Well, what would you do to each one? Yeah. So we want to factor. So up top we get x times x minus 2 because it's GCF. Or GVC, I guess. And on the bottom, we get 2 times x minus 2. What's this one look like in factored form? X times x plus 2. Can you do anything with one or more or both of them? Anything more? Yeah, you can cancel these out. And remember, when you cancel things out, a hole will exist. So because that's the difference in the behaviors. Because I was able to cancel out the NPV here, hole in this graph. No vertical asymptote, just a hole. Here I can't cancel anything out. So there's going to be a vertical asymptote in this graph. A vertical asymptote in this graph. That's the difference between the two. Okay. So most of the time we're going to get a vertical asymptote. Sometimes in one special case, the speed bump one, we didn't. Okay. Sometimes the NPV, the vertical asymptote, will cancel out with something in the numerator and become a hole. Okay. Now, the horizontal asymptote. This is something that you're going to have to commit to memory. Every graph we've done to this point, except for the one where the horizontal asymptote shifted, okay? Do you remember what the degree of an expression is? The degree represents the highest exponent in the expression. So if I gave you an expression x to the third plus x plus 3, what's the degree of that one? 3. If I said x squared minus 2x plus 4, what's the degree of that one? 2. If I said 2x plus 5, 1, right? Because if there's no exponent, we always assume it's 1. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is always the x-axis, or y equals 0. Those were all the previous examples we did, like here. What's the degree of this one? Well, there's no x, so there is no degree, is there? What's the degree of this one? 1. So this is less than this, which means there's a horizontal asymptote there. Same idea with here. What's the degree of this one? None. What's the degree of this one? 2. So this is less than this, which means there's a horizontal asymptote at y equals 0. Yeah. The degrees are the same. You find the asymptote by dividing the degree of the coefficient at the top by the coefficient of the bottom. So let me give you an example. So here, if I said y equals 2x plus 5 over x plus 1. What's the degree of the top? What's the degree of the bottom? So they're the same. So I take the numbers in front of the 1 exponents, 2 and 1, and I divide them. So the horizontal asymptote will be at 2 divided by 1, y equals 2. That's how you find it. Okay? That's perhaps the trickiest one to remember. If the degree of the numerator is higher than the denominator, there's no asymptote. There's no horizontal asymptote. So like if I had y equals x squared plus 5 over x minus 1, no horizontal asymptote, because the degree of the top is 2, the degree of the bottom is 1. So because 2 is greater than 1, there is a horizontal asymptote. So let's just practice with this, keeping those 3 things in mind. So what we want to do is we want to state all the asymptotes and any holes if there are any. Okay? Well, first of all, we should factor if we can. And I can factor the bottom to what? Plus 3x minus 3. Okay, so the horizontal asymptote what's the degree of this one? 1. What's the degree of this one? 2. So if it's less, if the numerator is less than the denominator, where is it? Y equals 0. So degree of numerator less than degree of denominator y equals 0. That's the horizontal asymptote. Vertical asymptote. Whatever values of x make the denominator 0. 3 and negative 3. But what letter do I have to put in front of those? Not just 3 and negative 3. X equals 3 and negative 3. And we didn't cancel anything, so there were no holes. So we don't have to worry about the holes. B. Can I factor anything? No, so let's go to the horizontal asymptote and look at the degree. The degree of the numerator is less than the degree of the denominator. Therefore, the horizontal asymptote is y equals 0. The vertical asymptote, what value of x makes the denominator 0? There is none. It's impossible to get it. So therefore, and there was no canceling, so there's no holes. So there's no vertical asymptote. Okay, next one, again. Factors, can't we? X plus 4 over so there's no more, like this cancels, and I'm left with 1 over x minus 4, right? So there's a hole. Actually, let's do these, sorry. I want to stay consistent. Let's do the horizontal asymptote first. What would the horizontal asymptote be? Y equals 0 again. We've had the same thing in 3 examples. Because the degree of the numerator is less than the degree of the denominator. Okay, so for the vertical, we know we have a hole at this non-permissible value, x equals negative 4, but do we still have a vertical asymptote? Yeah, there's still one here, because this is still on the bottom. So not only is there a hole at x equals negative 4, there's also a vertical asymptote at x equals positive 4. So it's going to look, I mean, just, I'm not going to draw a detailed sketch of it, but it would look something like this. Horizontal asymptote is there. Vertical asymptote is out here at 4. And it would look, well, it might, yeah, I'll do this. And it would look something like that. It would take that kind of shape, but it would have a hole in it. Okay, we'll see one like that at the end. Okay. Horizontal asymptote, first of all, can I factor? No. Horizontal asymptote. What's the degree of the numerator? And the denominator? What happens to the horizontal asymptote when I do that? I've got to take this coefficient, divide this coefficient. So the horizontal asymptote will be 4, y equals 4 divided by 1 equals 4. I didn't cancel, so there's not any holes, but there is a vertical asymptote where x equals 2. Okay. There's a few of these, but I want to make sure you really understand it because, like I said, these can be a little nasty sometimes because there's just so many different shapes. But if you follow certain patterns, you can get them. All right. Can I factor?
Yeah.
Yeah. So let's do that first. X plus 1, x minus 1. Let's go to the horizontal asymptote by looking at the degree. What's the degree of the top?
2.
Degree of the bottom? 2. Therefore, the horizontal asymptote is going to be this number in front, which is 1, divide this number in front, which is 1. So the horizontal asymptote is y equals 1. No canceling, so no holes. There are 2 NPVs, which means there are 2 vertical asymptotes, 1 and -1. Next one, can I factor? No, this is not a difference of squares. Okay, horizontal asymptote. What's the degree of the numerator? 2, degree of the denominator. Therefore, it's going to be the coefficient of the x squared up top, 3, divide the coefficient of the x squared on the bottom, 1, y equals 3. Vertical asymptote. Somebody's shaking their head, and I'm assuming that's going to be none, which is correct. Because there's no value of x that will make the denominator 0. We're done. Factoring? Yeah, this one I can. Numerator factors 2. X plus 4, x plus 1. X plus 1 on the bottom. I'm going to do the horizontal first before I cancel. Somebody tell me what the horizontal asymptote would be. 1. What's the degree of this? Degree of this? If this is bigger than this? No. If this is less than this, it's y equals 0.
No.
If there is none. If this, remember, degree is greater. Degree of numerator, I'll write that actually. Degree of numerator greater than the degree of the denominator. And whenever that happens, it's none. No HA.
vertical asymptote. Now I look at cancel, which you should be able to see we can do.
Notice we canceled the denominator completely out, didn't we? Therefore, there's no vertical asymptote, is there? But there is a hole. So no vertical asymptote, but a hole at x equals what? -4. Okay. And the last example, horizontal asymptote. Oh, sorry, can I factor? No. Horizontal asymptote? None. Same reason as before. The degree of the numerator is greater than the degree of the denominator. No canceling out. Vertical asymptote? X equals 1. Yes. Yes. Okay. She's doing her job. Leave her alone. She's doing her job. Good for her. Oh. Yes, I'm sorry, mine are boring white. Okay, so we got a whole bunch of different graphs now for rational functions. How do we approach these? Let's approach it the way we just did the previous question. Make sure it's factored. Get the asymptotes, get any holes. That's the first thing we want to start with. So this one, is it factored? Yes. Horizontal asymptotes. What's the degree of the numerator? Degree of the denominator. Therefore, the horizontal asymptote is the number in front of the one exponent up top divided by the number in front of the one exponent on the bottom. Oh, sorry, this is y equals not x equals. A mistake. So y equals 2. Vertical out, well, first of all, there's no canceling, right? So therefore, there are no holes. Vertical asymptote is where? X equals -2. So let's graph what we've got right now. Let's graph what we've got right now. So we got 2 and -2. So we know we're going to get curves and they're not going to touch these. Okay. Question is, we need some points. Okay. Yeah. Oh, did I mix it up? Oh, no, I got it. Yeah. So, what are some points we could get? Well, we could get the intercepts. So the y-intercept, well, how do I find the y-intercept? I make x equal to 0. So therefore, the y-intercept is going to be 2 times 0 plus 3 over 0 plus 2, which is 3 over 2. I'm actually going to put a decimal. 1.5.
So the y-intercept is 1.5. Where's 1.5 of the y? Here, right?
So I know part of my graph is going to be in this section, isn't it? Which means that it's a pretty safe bet that the other part is going to be in this section. Okay? Well, I can find the x-intercept
By making y equals 0. So when I do that, I'm going to get 0 equals 2x plus 3 over x plus 2.
How do I solve that? What's that? Yeah,
Times both sides by x plus 2 to get rid of the fraction. So those will go. And what's 0 times x plus 2? Still 0. So 0 equals 2x plus 3. Therefore, negative 3 is equal to 2x. And therefore, the x-intercept is equal to negative 3 over 2, or negative 1.5. Where's that? Negative 1.5 is there.
Can we see how the curve shapes now in this section?
You should be able to see now that it goes like this. But remember, if something's happening here, unless it's a square, something's going to happen in the opposite corner. So I need a point over here. That's why I listed other points. Okay? So what would be a good point I could find over here? Well, just go one to the left of this asymptote. So this is negative 2. Let's see what happens when x is negative 3. Okay? That's another point. Let's see what happens when x is negative 3. And sorry, y-intercept is 1.5. This is negative 1. So I have to plug negative 3 into. So y equals, what is it, 2 times negative 3 plus 2. Sorry, plus 3. Divided by negative 3 plus 2. Well, 2 times negative 3 plus 3. So I got negative 3 up top divided by negative 1, which works out to plain old 3. So negative 3, 3. So negative 3, 3. There it is. And we know it's going to take the same curve shape and go along the asymptotes. So there's our graph.
So establish the asymptotes, establish some points, and that will tell you what the curve looks like.
Okay? One more example. Oh, sorry. The domain and range.
Could we potentially find another point? Like, not just x equals negative 3, but also like x.
Negative 1?
Yeah.
Sure.
Okay. Then we go towards the main process we want with the.
Yeah.
Okay.
Sure. What are you up to?
A week.
Oh.
So.
Okay.
Anyway, we'll finish the last example you can watch
Okay.
when I post it. Okay.
Domain. Remember we said with this one, let's not write what the domain is, let's write what it isn't.
So what x can be, and remember, we go to the left forever, we go to the right forever.
But there's one x value we don't touch.
What's the one x value we won't hit? Goes to the left forever, doesn't it? And then it comes all the way up to here, but it doesn't get this line, does it? What's the value of x to this line? That is the domain. X cannot be -2. The range goes down forever, goes up forever, but never hits 2. So y cannot be 2. Okay, last example. First thing you want to do. Factor. And I can factor the bottom. What is the bottom factor to? X. X minus 2.
I'm going to do some canceling, so that's going to create a hole. But there still could be a vertical asymptote.
But let's do the horizontal first by looking at the ratio. What's the degree of this? Degree of this? And if this is less than this, 0, y equals 0. There is a hole at the binomials I
Canceled out.
So there is a hole at x equals 2. But I have to find the corresponding y value. When x is 2, isn't y equal to 1 over 2 minus 3? Because all I do is plug 2 in here and do 1 divide 2 minus 3. What's 1 divide 2 minus 3? Sorry? 1? Negative 1. 2 minus 3 is negative 1. 1 divided negative 1 is negative 1. Is there still a vertical asymptote? Is there still something on the bottom? Yes. What value of x makes this 0? Sorry? 3. So therefore, there's a vertical asymptote at x equals 3. Let's graph the asymptotes and the hole. So the asymptote y equals 0 and x equals 3. So y equals 0, x equals 3. And where was the hole again? At what point? Negative 3, negative 2, negative 1. Negative 2, negative 1. Oh, well, like negative 2, negative 1. So it's here. What's that? I don't know. I asked you guys, so I didn't have to scroll up here. It's 2, negative 1. I heard somebody say negative 2, negative 1. So 2, 1, the hole is there. So I'm going to have a curve there. So really, this can count as a point. I know it's going to go like that. Okay, I don't need to find the y-intercept here. Because I know this and because I know it's going to be a curve along the asymptotes, that's good enough. Remember, you're asked to sketch these things, not like draw them exactly. So I don't need the y-intercept here. I don't need it. Just by looking at the graph, there's no x-intercept, is there? Because it can't hit the x-axis. There's an asymptote at the x-axis. So there's none. So that doesn't help me. But I need another point. Where's the rest of the graph?
what section would it be in? Upper left, lower right, upper right? Where would it be? Upper right, because they're opposite corners to each other, right?
So I need to pick a point over here. What do you want to pick for X? Sure, we do 4. That works perfectly. Just do 1 after the asymptote. And so we end up with y equals 1 over 4 minus 3, right? Which is?
Which is one.
1. So therefore, 4, 1 is a point, and it takes the same curve shape.
There's our graph. What would the domain be?
Remember, this is the one when we do x cannots and y cannots. X cannot equal 3.
Is there anything that else that x can't equal? What about where the hole is? 2.
So x cannot equal 2 because there's a hole here. X cannot equal 3 because there's a vertical asymptote here. So we would say 2, 3.
What can't y be?
0.
Okay.